In section 2.3 of our review unit, we're going to go over the order of operations. So our learning goal and essential question for this, of course, is why is the order of operations important? Of course, we're going to learn how to use it as well. All right, so let's consider the expression 2 times 3 minus 1. There are really two operations in this expression. We have multiplication and we have subtraction, right? So remember we talked about the operations are multiply, divide, add, and subtract. So those are our operators. So we have those two operations. So it matters which operation we complete first to find the value of this expression, in other words, to evaluate it. So if I were to subtract first, then I would have 2 times 3 minus 1 is 2, and 2 times 2 is 4. So evaluating that expression with subtraction first gives me 4. But if I were to multiply first, then 2 times 3 is 6, and 6 minus 1 is 5. So we get two completely different values depending on which operation we perform first. So that's why it's really important to use the order of operations. We want to make sure that no matter who does the problem, we all get the same answer because we're following the same order of operations. Which operation do we perform first? Let's look at another example. This one was similar to a problem that you guys had on your test where you had to add or subtract 4 different numbers. This time we have 3 operations, right? We've got the first addition, we've got subtraction, and then we have another addition. So let's see what happens when I create two groups. Like we can add 4 plus 2 together and get 6. And we kind of have a second group here, 6 and 3. 6 plus 3 is 9. And then if I'm to subtract 6 minus 9, notice that my signs here are opposite. This is really positive 6. So we subtract the numbers. 9 minus 6 is 3. And take the sign of the larger number. So 6 minus 9 is negative 3. But what happens if I don't create two groups like this? What happens if I just add 4 and 2 together? We get 6. So then we have, oops, not 6 plus. Let me fix that. 6 minus 6. There we go. 4 plus 2 is 6. 6 minus 6 plus 3. And now we do 6 minus 6 next. So we get 0 plus 3. And 0 plus 3 is positive 3. So we get completely different results. One is positive and one is negative. Which one is correct? Well, I hope you know. This one is correct. So let's go through the order of operations and discuss how you know which way it is correct. Alright, so we often use this PEMDAS to help us remember what the order of operations is. Or sometimes people say, please excuse my dear Aunt Sally, just as a way of remembering what the order of operations is. So instead of thinking about this word like this, I want you to actually think about it like this. Separated a little bit. We got the P, we got the E, we got the MD together, and we got the AS together. And this is how I'd actually like you to write it on your paper. Okay? So let's go through each of these things. P, of course, stands for parentheses. But it's not just parentheses. It's actually parentheses and any other type of grouping symbol. There's actually lots of different grouping symbols, and we'll discuss those later in the notes. E, of course, stands for exponents. So first we want to do any operation that's in parentheses or a grouping symbol. Then we want to evaluate any exponents that we see. MD stands for multiplication and division. And this is really important. I want you to write it in your notes and underline it or highlight it or whatever. Multiplication and addition have to go from left to right every single time. Don't just do what's positive first. Don't do the multiplication first and then the division. It goes from left to right. And then finally, of course, AS stands for addition and subtraction. And again, those also have to happen from left to right. Don't do all the addition first and then all the subtraction. Go exactly in the order that you see the operations on the page from left to right. So example 1, let's evaluate the expression for x equals 4. So first, whenever you have an algebraic expression and you're plugging in a value for x, think about what the operations are that you see. This really means 3 times x squared plus 4. So if I were to plug in x squared, or excuse me, if I were to plug in x equals 4, then my expression becomes 3 times 4 squared plus 1. So thinking about our order of operations, PEMDAS, we don't have any parentheses, so we're good there. We do have an exponent, so let's evaluate that exponent next. My exponent is 2, so I want to first evaluate 4 squared. 4 squared is 16. And then remember, we were multiplying that times 3 and then adding 1. So in my order of operations, multiplication and division comes next. I don't have any division, but I do have multiplication. So next we'll multiply together 3 times 16, which is 48. Now we perform the addition and subtraction last. So my final result is 49. Let's look at example 2. And these examples really show us how to use the left to right rule. So you can see in like the first one I have 24 minus 8 minus 6. So it's all subtraction. So we know we perform subtraction from left to right. So in this example, the first thing that we have to do is subtract 24 minus 8. 24 minus 8 gives me 16, and then we'll subtract 6. So 16 minus 6 is 10. Yeah, that's from last night. It's old. Not very good. Remember, no talking. In my second example, I have multiplication and division. So again, from left to right, we actually have to multiply 15 times 2 first. That's 30. And now we divide 30 by negative 6. So positive divided by a negative is negative, and 30 divided by 6 is 5. So then let's do just one more. That kind of combines both. Now here, since we have the operations addition here, multiplication here, and subtraction here, we don't just go from left to right. Remember, our rule says do all the multiplication and division first. So I have to take care of this multiplication piece first. So the first thing I'm going to do is multiply together 4 times 2. That's 8. So then if I write down the rest of the problem, it's 16 plus 8 minus negative 3. Now we do the addition and subtraction in order from left to right. So first, I'm going to add 16 plus 8. Well, 16 plus 8 is 24. And now we're subtracting negative 3. So, because we're subtracting, remember what we can do here. We can make this addition. We turn subtraction into addition by adding the opposite. So I'm going to make this subtraction into addition, and I'm going to add the opposite of negative 3, which is positive 3, and 24 plus 3 is 25. So that's my final answer for this example. All right, let's talk about parentheses and grouping symbols, which I said we would talk about at the beginning, that we would get to this. And so even when we talk about PEMDAS, you know, we say P-E-M-D-A-S. This P means parentheses, right? But really it means any kind of grouping symbol. So when you're completing the order of operations in a problem, I want you to think about, yes, parentheses. So of course complete any operations inside your parentheses first. But there's other things that act like grouping symbols as well. For example, absolute value bars act like parentheses. So you're going to complete any operations inside absolute value bars first. Another thing that you might not think of as a grouping symbol is a fraction bar. They also act like a grouping symbol. So if there's any operations in the numerator, do those first. And if there's any operations in the denominator, do those first before you do the division that a fraction bar is telling you to do. So let's look at some examples. Here in number 1, or part A, we have 7 times 4 divided by 3 minus 1. So according to my rules, I have to do the operations in the numerator first. It's kind of like there's parentheses around 7 times 4. Well, 7 times 4 is 28, and 3 minus 1 is 2. So if I do the numerator and denominator first and then divide, I get 14. In the second example, we want to evaluate the expression for x equals negative 1. So this means it's really 2 times negative 1 divided by negative 1 squared minus 1 plus 5. So let's work that out. Doing the operations in the numerator first, I'll have 2 times negative 1, which is negative 2. Now working on to the denominator, I have to do my exponent first. So negative 1 squared is negative 1 times negative 1, which is positive 1. Now we have 1 minus 1 plus 5. So doing the operations in the denominator in order from left to right, 1 minus 1 is 0. And of course, 0 plus 5 is 5. So my final answer would be negative 2/5. Okay, so that's all we have for the examples here. Again, 3 to 4 sentences for your summary. Go ahead and put your questions on the left-hand column, and we'll discuss them in class.